Okay, so we're looking at 2011 BC3, Form B. All right, so the issue here that we have is that we have a region that's made up of a square root function and also a 6 minus x function, and they must find the area of it. The major issue that we have here in the area part for part A is that the square root and the line make two different tops, if you will, for this region. So we've got a couple ways to proceed here. I guess one of the ways we could do it, of course, would be just to split that up into two regions, from top for the first part being the square root function and the other being the line, and we know that that intersection point is 4, 2. We can figure that out by setting them equal to each other, or we could just look at the picture because they told us what the intersection was, which is convenient. All right, so that means that area-wise, if we find the area, we should have went 0 to 4 of square root of x dx. Keeping in mind that this is not a calculator problem, so we got x to the 1/2, antiderivative would be x to the 3/2, over 3/2, or 2/3 times. We put 0 and 4 in there. 4 to the 3/2, remember if we do square root of 4, that would be 2. 2 to the 3 would be 8. Times 2 would be 16 on top, so 16/3 for the first part, minus 0. So we get 16/3 for that part. The other part here is just a triangle. We could do it with an integral if we wanted to, but ultimately it's just a triangle, so we could just recognize that it's a 2 by 2? 2 by 2 triangle, so 2 times 2 times 1/2 would be 2. So we'd add the triangle to that, and we'd get 22/3. The final. And the point breakdown, that's worth 3 points, which in the scheme of things, if we get 3 points like that, that'd be nice, huh? Pretty easy 3 points, I would hope, at this point for us. But
is that one on the AB?
Remember, some of the problems are AB/BC problems. So if it looks familiar, that might have been an AB problem as well last year. So there's obviously the BC problems are pretty easy to identify, but wasn't.
Okay, I just have a question kind of about the test. So we're looking at dates today. Like, do we take our test with the AB students?
Same day.
Okay.
Yep. Yep.
What day is that? I got the date.
May 9th or something.
I got this.
Let's see. So bottom line here, point breakdown. If you wrote the integral correctly, so if you had this integral for the first part, that's a point. If you had the antiderivative correct, the 2x to the 3/2 over 3, or x to the 3/2 over 3/2, you had that correct, that was worth 1 point also. And if you had the final answer correct by adding the 2 in there, another point for that, so 3 points total on that one. So 1 for the integral, 1 for the antiderivative, 1 for the answer, so 3 total. All right, let's move on then. Part B says that the region R is the base of a solid, and says for each y, where on 0 to 2, where y is perpendicular to the y-axis, is a rectangle. Okay. All right, so perpendicular to the y-axis would mean that these rectangles are horizontal, if you will. And remember, these are going out into space, up at us, if you will, out from the paper, the board, whatever the case may be. Those are rectangles, each of those slices. Okay, and it says that the rectangle with the base lying in R has a height of 2y, and our job here is to write but do not evaluate an integral that would give us the volume of the solid. Okay, all right. So let's think about this rectangle here that I've drawn, and think about what its dimensions would be. Well, we know that this dimension right there would be 2y, because it says it has a height of 2y, if you will. The base is in the plane. The height of it is 2y. So that dimension being 2y would give us one of our dimensions for the rectangle that we're looking at here in front of us. And the other dimension is going to be found by doing, in horizontal sense, we're always going to do, remember, right minus left, not left minus right. So it would be 6. We have to write it in y, of course, so we'll have to change these to our g of x function was y equals 6 minus x. And so therefore we'll have the solve for y, or solve for x, that is, we'd have y plus 6 equals x. And then the other one was y equals radical x, so we get y squared equals x. So we first want to write them in terms of y instead of in terms of x. So we're using horizontal here, which means we're integrating in y. And so if we do the right one, we'd have y plus 6 minus y squared. And again, that right there would be an expression for the area of that rectangle. So it's going to be the right minus the left, and they're written in y when we have anything horizontal at all. Questions on the expression for the rectangle? No?
Y equals 6 minus x would be
Uh,
y plus 6.
Oh, you know what? Did I do that wrong? What did I do here? Oh, you're right. I got this backwards. Right. X minus 6, sorry. No.
Wouldn't it be 6
This
minus
is,
y?
I'm going to read my own writing here. Oh, I went backwards. I went this way. So, this is 6 minus x. So if I, yes, 'cause we're going to add, yeah, 6 minus y, sorry. Thank you. Thank you for looking at that funny, because I missed that one. Alright, so ultimately it'll be 6 minus y, then minus y squared. Okay, we solved that correctly. So, not that. We get x equals 6 minus y. Alright, so now that we have that straight, again, that right there would be our expression for the area of the rectangle. And then ultimately, if we want to add up the volumes of all the rectangles, we would write an integral then, 2y, 6 minus y squared. And I don't know how, that's not multiple choice, so I guess simplifying wise, we just go 0 to 2 because we're in the y direction. Okay. And then right there we do it. I mean, there's really no good reason to multiply that out. It's not going to be wrong if you don't multiply it out. Okay. And I guess that's it. Just if you had the integrand right, the 2y and then 6 minus y squared, that's 2 points for that. And then 1 point for the final answer, which ultimately means an integral with 0 and 2 on it. So 3 points total for that part. Questions on part B? All right. Part C then says here that there's a point on this graph, there's a point P on which the graph of the line that's tangent to F is perpendicular to the graph of G. So just thinking about, if I were to pick, just say that point right there, and I drew a tangent line right there, ultimately, picture-wise, at some point, we're going to have a tangent line that's going to be perpendicular to the given line, 6 minus x line. Okay. So our job here is to see if we can figure out when that's going to be. Okay. So we know that the slope of that line in question here, keeping in mind we're talking about perpendicular lines, we know something about the relationships of their slopes, and therefore something about their derivatives. Okay, so ultimately the line here in question that was given has a slope of -1. So g prime is -1, we know that. Okay. And then the line in question here, the one line that we're trying to find, the tangent line if you will, its slope then, and actually I won't call it f because they called it f, but ultimately wouldn't f at x have to be equal to 1 in order for this to be the case? Okay, the derivative would have to be equal to 1 at this point in question. True? And so, knowing that our derivative has to be 1, okay, if we find the derivative of our function being f of x equals radical x, the derivative of that is going to be, if I write x to the 1/2, it's going to be 1/2 x to the -1/2. So it would be 1 over 2 radical x would have to equal 1. Right. Remember, at this point in question, that point we're trying to find right there, the derivative would have to be 1 for tangent. And so if we do the math on this, we can solve for x. If we go 2x or 2 radical x equals 1, do the cross product. So radical x would equal 1/2, so x would be 1/4. And in the scheme of things, how does 1/4 look just picture-wise? Roughly 1/4 seem like it'd be reasonable. We had x equals 1/4. If we drew a line that was tangent to that curve, go up and be perpendicular to that 6 minus x line. Seemed reasonable at least, right? Okay. So with that, the question though, remember, is find the coordinates of P. So far we found coordinate of P, right? So we need the y coordinate, and if we put the y coordinate into the curve or the line, remember it's a point on the curve. So therefore, if we put that into radical x, we're going to get 1/4, 1/2. And that would do it. So at that point, 1/4, 1/2, we'd have a tangent line here, and it would be perpendicular to the other line because again its slope would be 1 there. And ultimately 3 points again there. 1 for finding the derivative. So if you found the derivative of f, you had something to do with that. You found the derivative correctly, you got 1 point for that. The next point was for writing the equation here, recognizing that the derivative had to equal 1, okay, because the other derivative was -1, so the opposite reciprocal. And then finally the answer, if you got 1/4 and 1/2, you got the third point there, and a total of 9. Plus,
Would you still get the point for the derivative if you plug that in like 1/2 x to the negative 1/2?
like this?
Yeah.
Yes. Yep. Yeah, there's no, it's still the derivative. It's not in the best form necessarily, but it's still the derivative, so you bet. Anything else on number 3? All right. Anybody get 9? Good. 1 down, 11 to go. All right. So let's take a look at here what we got on number 4. They give us the differentiable function on 0 to 10. They tell us some of the areas. They also tell us some of the curve lengths, which makes this a BC problem. Keep in mind because the curve length part of this would be a BC application. No curve lengths in AB. The whole problem really is an AB problem until you get to part D, though. Ultimately, we're asking for ultimately the average value of our function, and we know that our average value of any function is the following in general. This. And we're looking for the average value on 0 to 5. So we know that 1/5 is out in front. We go from 0 to 5. And we have f of x dx here because our f function is what we want the average value of. And we know that we don't have an equation for f here, so there's no way to find an antiderivative. But what did they tell us? Didn't they tell us the area under the curve there? Yeah, the area under the curve is 10. Keeping in mind, though, it's below the curve, so it's actually, the answer to this is actually -10. So ultimately we get -2. So only 1 point for that, unfortunately. Questions on part A? All right. See what we got here in part B. We got to evaluate the integral from 0 to 10 of 3 f of x plus 2 dx. And once again, keeping in mind that it's just an integral here, if we break this up and we write 3 0 to 10 of f of x, and then 0 to 10 of 2, we could set up ourselves a couple of integrals here just using our properties of integrals. And we ultimately know the antiderivative of this. We don't need to know the antiderivative because the area from 0 to 10 is going to be, they told us it's the two areas underneath this, which is 10, and the other one is reading again here. So 0 to 5. Oh, there it is up front. I'm looking at the wrong part. The curve length is 11. So it's 10 and then what, 27 it says? So 10 and 27. Of course, one of them is negative, the 10 is. So actually this answer here would be 17. And then the antiderivative of 2 is 2x on 0 to 10, which ultimately is 20 minus 0, which is 20. So if we do the math correctly, we should get 51 plus 20 would be 71. All right. Then that's it. Okay. 2 points just for the answer. So if you got 71, you're good to go. You got 2. No breakdowns or anything other than the right answer here. Questions so far? Alright, let's carry on then, part C. Part C says that assume that g of x is an integral function from 5 to x of f of t dt. And the question says on what intervals of, if any, is the graph of g both concave up and decreasing. So let's start with the decreasing part, since we know that has to do with the derivative. So we want to know concave up and decreasing. So concave up is going to be when g prime is, when decreasing is going to be when g prime is negative. So g prime here, though, remember, is just f of x. It's the integrand evaluated at the upper limit. Okay. So ultimately, we're looking at a picture of g prime. So when is it negative? Because that's when g would be decreasing, is when its derivative is negative. It'd be negative on the 0 to 5, wouldn't it? Questions so far? All right, and then what about g double prime? Because we want to deal with concavity for g. Obviously, g double prime would be the derivative of f. So the derivative of our picture, and again, we want it to be concave up. So concave up would mean when f prime is positive. So the derivative, it looks like it's positive on 3 to 8. Would be where the derivative is positive. And remember, at this point, now we want to know when is it going to be concave up and decreasing. So ultimately, what would be the overlap of these two sets? It would be from 3 to 5. If we do these on a number line, we go 0 to 5 and then 3 to 8. The overlap part would be 3 to 5, wouldn't it? So ultimately, if you did this part, if you found the derivative of g, which is f prime, you got a point for doing that. And then answer and reason. Ultimately here they have asked us for explain your reasoning, so we'd have to write some words here along with this as well. You know, basically what I said in words and verbally, but bottom line here is that we're decreasing because g prime, which equals f, is negative. And here we're concave up because f prime is positive. And ultimately the overlap of those two intervals will be the 3 to 5, and we'll be good to go. So 3 points total on that one. If you had the right interval. Like I said, if you got this point, this part here, at least you got the fact that the derivative is f, and answer with your reason. Okay. Good to go. Questions on part C? Anybody still in for the 9 yet? Like I said with the multiple choice, this is start making yourself some notes about things, about how you're missing points and what things that we need to get better at and study and whatnot. So, like I said, only you know exactly what you did. So, if I were you, I'd start making some notes because it'll help me help you if I can see what problems you're having. Okay. All right. So this last one here we have says that the function h is defined by 2f of x over 2, and h's derivative is f prime at x over 2, and we want to know what's the arc length of h from 0 to 20. Now, in general, they gave us some arc lengths here, but they were arc lengths of f. Keep that in mind. So we want the arc length of h, but ultimately the arc length of h in general is going to be from 0 to 20. And remember, if we have arc length, and remember this is not a parametric situation, it's just a f of x situation, which means that this is always going to be 1, and then this is going to be the derivative of h squared. So that being our arc length formula, we would need to figure out how to evaluate this, because that is the arc length of h on 0 to 20. Okay. All right, so ultimately we know some stuff about arc length for f, so somehow we need to introduce f here because we really don't know much about h. So one thing that we do know about h and f together is that h prime is equal to what? They told us h prime is equal to f prime of x over 2. one issue that we have here also in dealing with this is that we don't have an x argument here. All right, because if we did have, I'm gonna show you something backwards after we get done here. If this was just plain old f of x, we'd be just about done. We'd already have the majority of our answer here. Okay? But there's one reason why we actually couldn't find the answer if this was just f of x. We'll discuss that in a minute. But bottom line here is if we want to, if we let u equal x over 2 and we let du then equal a half dx, and keep in mind that this is an integral here, so they should have dx on them. And we go 2 du equals dx. Then our substituted integral becomes, excuse me, if we write our 1 plus f prime at u squared du, right? And keep in mind that the 2 would have to come out in front. We're replacing the dx here with 2 du. So now we're getting something. Now we're getting somewhere, because remember, if I just had 1 plus the derivative of f squared, isn't that an arc length for f? Just like this was an arc length for h, isn't this now right here, isn't this an integrand that looks like an arc length for f? And didn't they give us some arc lengths for f? Okay. Now we got one issue though, and that's what about these? Again, this part is perfect. That's exactly what we wanted. We want something that we can, that's an arc length integrand, because again, we don't know what the f function is, so there's no possible way to do an antiderivative and actually evaluate this. But if we can get it to look like an arc length, and they gave us arc lengths, then we can go to work. Now, here's the issue though, is that our former a and b were 0 and 20. Well, if we change those to u values, then we can make this an integral in u, which is nice. We put 20 in there, we get 10 here, and we get 0 here. So ultimately, what do we got here in this expression? 2 times, isn't that what I just parenthesed? Isn't that the arc length of f from 0 to 10? True? Which is nice because we already know that. What is it? 0 to 5, the length is 11. And 5 to 10, the answer is 18. So ultimately, it turns out to be 29 divided by 2, 14 and a half. Or, nope, times 2, not divided by 58. Right? So, ultimately, again, this one was a little bit tricky, I guess, just because you had to recognize that there's really no possible way to actually evaluate this because we don't know what f is, and there's no way to find an antiderivative for that. Okay, and so therefore we're going to use some of our wits, I suppose, to try to rewrite it into an arc length integral that we know. I mean, they gave us those arc lengths of f, so it should be something. Most of the time, they give us information that we usually use in some way or another. Okay? So it would be hard to believe they would just give it to us for nothing. Okay? All right. So again, ultimately, start out just by just writing down what we know, even though we don't know anything about h. Okay, we know the arc length of h is going to be from 0 to 20 of the integral of, or the square root of 1 plus h prime squared. That's just our general formula. Okay. They gave us the relationship between h prime and f prime, which we can put in there. Okay, and like I said, this would be almost good right now, except for the x over 2 here. Okay, is not the curve that we have in front of us. It's not the curve they told us lengths about. But if we put it in the form of that by using u substitution, okay, what winds up happening is we got 0 and 10 here, which is perfect because we only know information from 0 to 10. The other reason this would have been impossible up here is because we're going from 0 to 20. Do we have information about what goes on from 10 to 20? So somehow we have to get the a and b down to 0 to 20 or 0 to 10 instead of 0 to 20 as well. Okay. All right, so ultimately you got 3 points for that, 1 point, and again, just if you knew the arc length integral, you get a point. So 1 out of 3 is better than 0, right? Okay. The substitution part, if you recognize that you need to do the substitution here to get it into a usable integral, you get a point for that. 1 point, not 2, and then 1 point for the 58. So that's a total of 3. Questions?